Okay, so today we're going to look at percent composition. So this equation right here you can write in your periodic tables for percent composition. It's going to be the mass of the element divided by the mass of the compound times 100% is equal to our mass comp. And so first thing, when we start looking at this, you are going to be given things like sodium hydrogen bicarbonate. And so you're going to have to be able to figure out the common or the chemical formula for that. So in this case, sodium Na has a +1, hydrogen +1, carbonate CO, and again polyatomic table, CO3 has a -2. The positives equal the negatives, so then the chemical formula for this is NaHCO3. So the first thing that we want to do when we're finding the percent composition is we are going to determine the molar mass. So in this case, sodium is 23, plus hydrogen is 1, carbon is 12, plus 3 times 16. And in this case, we add these up and we get 48 grams per mole. Now, if you look in your book, they have you go through and put, 1 mole of Na over 1 mole Na over 23 grams of Na. And that would get you 23 grams of Na. And then they have you do that for each one of them. This is just the shortened version of the same thing the book does. Okay, once we have that and we've determined this, we want to find the percent of each of the ingredients in sodium hydrogen bicarbonate. And so that means we are going to do this for sodium, hydrogen, carbon, and oxygen. And so we're just going to use our equation that was above. We're going to put the mass of the element. So sodium, we have 23 over the mass of the compound, which is 48 times 100. In the case of sodium, you would get 27%. Hydrogen is 1 over 48 times 100, and you get 1.2%. Again, we're labeling each of our elements. Carbon, 12 over 48 times 100. Ooh, my pen doesn't want to work. And in this case, you get 14.3% carbon. And we do our last one. You have 3 times 16. That is going to be 48 over 84 times 100. And we get a total of 57% oxygen. Now, if we add these up, you should get close to a roughly 100%. Now, I rounded some of these, so that's why you're not going to get exactly 100%. And if I wrote out to the 10 spot for everything, we should equal 100%. That's kind of your double check for these problems, is that you get 100%. Okay, so let's do a couple more. So let's do the percent composition for phosphoric acid. So let's arrow down just a little bit. Okay, phosphoric acid, again, we're looking at this element right here. We have to make sure that we have the chemical formula. This is an acid, so ic goes to 8, so that would be phosphate. So phosphate is PO4, has a -3 charge. We always have hydrogen first, +1. So the chemical formula for this is H3PO4. So again, we find the molar mass of this. So we have 3 times 1 for our hydrogen plus phosphate. Phosphate is 31 plus 4 times 16 for our oxygen. And we get a total, when we add those up, of 98 grams per mole of phosphoric acid. So we're going to do this for each of the elements. So we have hydrogen, phosphate, and oxygen. So we have 3 hydrogens, so you have 3 over 98, because we're using that mass of hydrogen, times 100. Again, 98 comes from our molar mass here. We get a total of 3% for hydrogen. We have 31, because we just have one single phosphorus, over 98 times 100. And in this case, you get 32% phosphorus. Oxygen, since we have 4 of them, we have to take 4 times 16. That gets us 64 over our 98 times 100. And in this case, we get 65 percent oxygen. So now if we add these up, it does total 100% because I went to whole numbers for everything. So what if something else happens? What if they tell you, hey, what about these 2 elements right here? Which one has the higher mass of sulfur? So the easy one would be like, oh, it must be this one because there's 2 of them, right? Well, that's not always the case. Because we have so many other oxygen and hydrogen, it could be the other element. So we have to solve this the same way. So basically we start with, since we're given the chemical formula for each of those, we're going to start with the molar mass of each one. So let's do H2SO4 first, and then we'll do H2S2O8. So H2SO4 is sulfuric acid, and so we have 2 hydrogen plus sulfur, and sulfur is 32. And I'm getting these numbers again from my periodic table, so they're not a mystery. We have 3 oxygen, and that is going to give me a grand total of 82 grams per mole of H2SO4. Okay, so now let's go to the next one. So we have 2 hydrogen, again hydrogen's 1, plus sulfur, well we have 2 sulfur times 32, plus we have 8 oxygen, oxygen's 16. We add those up and we get 194 grams per mole of H2SO4. Okay, so now we don't have to do hydrogen, we don't have to do oxygen because it's just asking for sulfur. So that's all we're going to do is percent for sulfur. So let's do sulfuric acid first. So we have only 1 sulfur, so we're going to put 32, so that's the molar mass of sulfur, over the molar mass of the compound, which is 82 grams per mole. And in this, times 100. And our percent composition for the first one is 39% sulfur. Okay, so let's go on to our second compound. Well, in this case, we have 2. So we have to take 2 times 32, and we get 64. We put that over the molar mass of 194 times 100. And in this case, the sulfur percentage is 32. So, which element has, or which compound has more sulfur? Sulfuric acid. So your H2SO4 has more sulfur. And so by percent. And so that's what that question's asking you. And so the percentage for this, tomorrow you're going to be doing a lab. And it's going to ask you to chew some gum. And so you're going to chew that gum, and you're going to determine the mass of the sugar that's in there. Just remember, save your gum wrapper so that you can put your gum back into that. So you should know the mass of your gum wrapper. You'll weigh that after you get done. Okay? Have a good day, ladies. Enjoy.